For too long, robots have been relegated to jobs doing repetitive motions in factories, doing work too dangerous or complex for humans, never getting to experience the finer things in life. But no longer. It is time for robots to make their way into the creative spheres. We believe that we have discovered the groundbreaking bot who will pave the way for all other robot artists. Its name, Vincent van Gogh-bot. Like all good artists, Vincent van Gogh-bot struggled to get to where he is now. But through hard work, practice, and dedication, the Van Gogh-bot is now able to produce fine masterpieces such as these.
The Van Gogh-bot, or as it's commonly called, the Van Gogh-bot, is an absolutely brilliant exploration that fuses science and art and crosses media. It asks us to consider whose work is valued and how we place value onto art, particularly in male-dominated fields of modern art and in the sciences. And it provocatively links all of these contemporary questions through its name to the writings of Van Gogh to his brother Theo about existential issues of the meaning of life and, of course, death.
Yeah, so I think the first important thing is the construction of the crossed arm mechanism. It's important, of course, because it's what holds the pens. The crossed arm mechanism is also responsible, in part, for the design that is produced. Its joints allow the different crisscrossing segments to move back and forth.
The other important aspect is the speed of the motors. The two motors move at different speeds because we have set each to a different power. Motor B is set to 100 while motor C is set to 98. This means that the position of the two segments attached to the gears change in relation to each other. This, in turn, causes the crisscrossing arm to expand and contract while also moving from side to side, creating the designs that are produced.
Our program is actually quite simple. We began with a tank block, which signals the motors to begin. As we talked about before, the two motors are set to different powers. Then we have to have a wait block that is triggered by sound. When the sound levels get above 90 decibels, this block is triggered and the motors stop because of that block.
This brings us to another important aspect of our design, the sound sensor. Originally, we would have the program stop after a certain amount of time, but eventually we realized that the design was not always complete in this time. So instead, we chose to use the sound sensor. With it, we are able to stop the bot when we feel that the design is complete. Stop! Okay.
Another aspect that we added on rather late in the game were the table clamps. Originally, we would hold the bot down ourselves to ensure that the bot didn't move as the pen moved, but eventually we decided to add these handy contraptions to minimize our involvement.
Yes, we spent quite a bit of time reinforcing our design so that it could hold up the arm mechanism without too severe of a tilt. If the gears tilt too much, then we get grinding, which is not ideal. We have several layers of Legos that help support the arm mechanism, and the extra securers attached to the axles are also key. Indeed, the gray cylindrical Lego below our largest gear was crucial in making sure that the gears wouldn't come loose and halt the drawing process.